Hi and welcome to this next video as we continue to bash our way through the huge amount of trigonometric content that there is on the A-level course. Hopefully you might have realised by now that Year 2 A-level is basically trigonometry with a shed load of calculus, differentiation and integration chucked into the mix as well. Those are the big three. So we're getting through it, and on we go to the next topic, which for this video is the double angle formulae. Now, the double angle formulae come from the addition formulae, and you do need to know these ones. They're not given in the formula booklet, and the reason they're not given in the formula booklet is because they can be easily derived from the addition formulae, which are in the booklet. So, double angle formulae, so we're talking about sine 2a, so an angle that's double the size of angle A. And what we're saying here is that, for example, if I take sine 60, it is absolutely not 2 times the sine of 30. Sine 30 equals half. Sine 60 is root 3 over 2. This thing here is not twice the size of that. If you think about the curve, that would be true if this was a straight line, but this trig curve is a curve, so there's no way that we're just going to say, well, okay, to get to sine 120, we just double sine 60. Absolutely not. Again, it's a classic mistake that sometimes that you see students making. So what we're going to do is have a look at, well, what actually is sine of double an angle. So here we go. If we take sine A plus B, and we're just going to pull a real simple trick whereby we're going to replace B with A, or alternatively make A and B the same size. Either way, what we end up with is that, which is sine A cos A plus cos A sine A, and you'll notice that this thing here is now exactly the same as that thing there. So what we've got here is sine 2A is 2 lots of sine A cos A, and there we go. So in order to get, for example, the sine of 60 degrees, we'd have to do 2 times the sine of 30 times by the cos of 30. Right, so that's that one. Let's do the cos of 2A, nice and simple again, exactly the same idea, do the replacing, so we end up with replacing cos B with an A, and you'll notice we've got cos A times cos A, here we've got sine A times sine A, so what we've got now is cos squared A minus sine squared A. Okay, now remember, if we go back to year 1, remember we had sine squared plus cos squared equals 1. Now we've got cos squared minus sine squared. Doesn't equal 1, it equals cos 2a. The other thing we can do with that one is we can take cos 2a, and there's actually 3 versions of it. Because what I'm going to do is use the sine squared plus cos squared equals 1, replace the sine squared with a 1 minus cos squared, and that gives us cos 2a equals 2 cos squared a minus 1. And in exactly the same way, replace this time the cos squared with a 1 minus sine squared, and we get that. So now what we've got is cos 2a just in terms of cos, and here we've got cos 2a just in terms of sine. And those are going to be incredibly useful. These two in particular are incredibly useful later on when you start integrating trig functions. More on that later on. Right, so we've just got the one version for sine 2a, we've got 3 versions for cos 2a. Again, not in your formula booklets, you need to know them. And then the last one is tan 2a, same trick, there it is. So now on the top we've got 2 lots of tan A, so it's 2 tan A, and there's a tan squared, so you get that one. And that is basically it. That is all the trig formulae that you need for your A-level maths. Now, 2 things. Firstly, it's vital that you know which ones are given in the formula booklet and which one you're expected to know. Again, as I said, I tend not to know them so much as I tend to derive them, because if I'm in an exam and I'm 99% sure I've got a formula right, there's still a 1%. And so I like to know I'm 100% sure, so I do that by re-deriving. And the other thing I would strongly recommend is you're going to be using these things a lot, you're going to get to know them, but have them easy access, front of your folder or whatever, so you've got an easy go-to place where you can have them all. And there they all are, so if you want to kind of screenshot that or do what you will with it, that is all the trig stuff that you need to know. Your reciprocal trig functions, your trig identities, your addition formulae, double angle formulae, and again, out of those 4 things, it's only this one here, it's only your addition formulae that you get provided with. Okay, having said all of that, let's move on and have a look at firstly an equation. So again, what we've got here is we've got our equation in terms of 2 angles. This angle here is twice the size of that angle there. what we've got to do is manipulate this so we've got it all in terms of just the one angle. So we're clearly going to do that by replacing this left-hand side with the formula that we just had, which is 2 sine A cos A. And now multiply out the bracket, move the sign over, we've got it equal to 0. Now we can do some factorising. And away we go. Now, I will come back to this, particularly this line here. There's a crucial bit in here, and there's a very good reason why I've done it this way. In a second, I'll go back and show you a way that you often see on exam papers from students, and why this version is the way to go, and not the version that I'll show you later. So, just to finish off, we've got sine theta equals 0, or 4 cos theta minus 1 equals 0. So from this one here, we've got sine theta equals 0. Gives us theta equals 0 to 180, 360. And from here, we've got 4 cos theta minus 1 equals 0, cos theta equals a quarter, and then we've got our 2 possible values there. So that equation actually gives us 5 solutions. Now, I want to just quickly go back to this line here and just do it in a slightly different way. So what I'm going to do is just multiply out the right-hand side, sorry, the left-hand side. So that gives us 4 sine theta cos theta equals sine theta. What you often find students doing now is dividing through by sine theta. So what we're going to get is 4 cos theta equals 1, which, mathematically is absolutely fine, nothing wrong with it. Notice if I follow that through, I end up with the cos theta equals a quarter. So that's going to give me this bit here, so I get those 2 solutions. But you'll notice what I've lost from this one is these solutions here. Okay, so you can guarantee in the marks, the answer marks will be for these 2. But if you end up with this situation, there will always be kind of an independent B mark, which will be getting solutions coming from this one as well. And that is the mark that a lot of students drop. So try to avoid doing that step there. What we need to do is take that over to the other side and then factorise as I've done in my example there. So that's just one for you to watch out for. Okay, so equation solved using a double angle formulae. Let's crack on and let's do an identity. So we've got to prove that tan pi over 4 minus x turns out to be this thing here. So again, start on the left hand side and work my way to the right hand side. So I'm going to start by using an addition formulae, which is going to be the one of tan a minus b, which is that, with my 2 values, pi over 4 being my first value, x being my other value. Tan pi over 4, hopefully we know that one, that's just going to be 1. So that simplifies, it now becomes that. That's not looking particularly nice, but it doesn't look like we can do a lot with it, except we've got to get it in terms of sine and cos. So I think the obvious way to go about doing that would be to replace the tan with sine over cos. So let's do that. Now we've got kind of fractions within fractions, so I'm just going to look at the numerator here, and I'm going to imagine that this 1 is just cos x over cos x. So that numerator is going to become cos x minus sine x all over cos x. And the denominator becomes cos x plus sine x all over cos x. And again, I'm going to do a little bit of scribbling here, because again, when I get fractions stacking up within fractions, my brain starts to twitch. So I'm going to write it slightly differently, and it might be you can spot this straight away without the need to do this. We've got divide by the second fraction, which is cos x plus sine x over cos x. Do the old keep, flip, change thing. So what we've got now is this fraction here is going to flip upside down. So I've got cos x minus sine x over cos x, that's my first one, times by cos x over cos x plus sine x. And there you go, you can see some cancelling going on. Now, if you're smarter than me, and most of you probably are, you'll realise you can just cancel. But again, I like to, it's just, we all think slightly different about maths. That's just the way I tend to deal with things. So, on we go. We end up there. Now, again, I'm going to pull a little trick that once you've seen it and you're familiar with it, it becomes more obvious than it possibly is at the moment. I'm looking at that, and straight my brain is thinking difference of 2 squares, because I've got essentially an a plus b there, and an a minus b there, and a plus b there. So I'm thinking somewhere along the line, I'm thinking about that one, because if I've got these things, these trig ratios as squares, I can do something with them. As they are at the moment, there's not a whole lot I can do with them. So that's what I'm going to do. I'm going to times top and bottom by cos x minus sin x. So on the top, there's my brackets there. On the bottom, there's going to be my difference of two squares. And we've got that. Now, the difference of two squares bit, I can do things with squares. For example, on the top here, for example, I've got cos squared x plus sin squared x. So those bits there are going to become 1. And if we have a look in the middle here, I've got minus 2 sin x cos x, and the eagle-eyed amongst you will realise that that thing there is simply sin 2x. So there's the top that we wanted. What's going on the bottom? Well, there you go. There's your cos 2x. That thing there, cos 2x, is cos squared minus sin squared. So, all of that turns into that. In the exam, you would need to demonstrate clearly that cos squared plus sin squared, putting those two bits together to make 1. So I'd be tempted to begin with in the exam to write this numerator as 1 minus 2 sin x cos x. And then next stage replace this bit with the sin 2x, that bit with the cos 2x, just to indicate clearly that what you're doing. Because it'll be a show that question, so you've got to prove very clearly how you're getting your results. Okay, on we go. And here we go. So we're going to use the addition double angle formula to express sin 3 theta in terms of theta. At A level, we don't really go a whole lot further than sin 2 theta, cos 2 theta. When you get onto further maths, for those of you doing it, you get the sin 3 theta, and that gets mixed up with a whole world of complex number stuff. But having said that, I have again seen this one. It appeared on the first exam in 2018, which I thought was a little bit unfair, or sorry, gave a bit of an advantage to further mathematicians. So let's just have a look at how we're going to deal with that one. So here we go, sin 3 theta, we're going to express it as sin 2 theta plus theta. Use the addition formulae to create that one. So this is our sin A plus B. Now what we're going to do once we've got that is, can you see here we've got a sin 2 theta, we've got a cos 2 theta. So let's use our double angle formula to replace that thing and that thing. There they are. Now we'll do some multiplying out the brackets. So I've got 2 sin cos squared theta. Over here I've got cos squared times sin. And I've got minus sin squared times sin, so that's where this sin cubed is coming from. Now we've got a jumble of stuff. We need it all in terms of sin theta, so I've got to clearly get rid of the cos squareds. And I can do that by replacing them with 1 minus sin squared. And so now multiply out. I've got everything in terms of sin theta or sin cubed theta. I've got 2 sin theta there, sin theta, and I've got a whole bunch of sin cubes in those 3 terms. Gather them all together, and there you go. And if in the exam you get asked to do cos 3 theta, you can do something very similar. Right. But again, it's just a little trick that you can pull, and again, a lot of A-level maths, particularly at this end, there's lots of little bits and pieces that just kind of help you along the way, and hopefully once you've seen it once, you'll remember it. And it's, once you get started and realise that you can write sin 3 theta, sin 2 theta, plus theta, everything else is just manipulation, just kind of follows on. So don't feel like you've got to memorise the entire thing. You've just got to essentially know what's going on with this top step. Okay.